Hello everyone, let's do the code for the heap sort. First, we want to have some functions to achieve the parent index access and the left child and the right child access. So let's assume the array we use the index start from 1. For the parent, I want to get the parent index if given the index of the current node. If I'm parent with the index of the current node and its parent will be I divided by 2. Then we can define a left function which given the current node index, its left node will be the I multiplied by 2. For the right part, I define it with the return I multiplied by 2 plus 1. Because everything I do is the swapping, and so we have a swap function which take I and j. I want to swap the I with j because I use the index start from 1 strategy. In real case, it will define a temp function to store the index, not I, because I should be do I minus 1. And then I change the content in I minus 1 with the aj minus 1. And then I assign the temp to the j minus 1. Okay, so this is the swap function. Let's test this function first. We have this array, which means that we have a tree like this: 2, 3, 54, 56, 2, 45, 6, 7, 8, 4, 56, and 7. So we have this, and this. Okay, so this is my tree. Alright, I want to check if the function is correct. So let me do a testing. Parent of 4, left of 4, right of 4. We run this, which is 2, 8, 9. Okay, so for the index 4, 1, 2, 3, 4. Okay, so it means 56, this value, right? Oh, not this, 56. It should be this value. 1, 2, 3, 4. Okay, this value. And then its parent node will be what? 2. Okay, 1, 2, it'd be 3, right? That's correct. And the left child is what? 8. Child is 8, so 1, 2, 3, 4, 5, 6, 7, 8, which is 7. And the right child is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 8. Okay, so the parent left, right are correct. And for the swap function, let's do print, because I have an array, print array. I want to do what? I want to do swap. Which one I want to swap? Swap a 0, 1 and 4. Alright. So run this. Name is not defined. So array. Okay. Array. Let's run it. So I swap 1 with 4. So I swap 2 with 1, 2, 3, 4. 56. Okay. So that's the swap is also correct. Then let's define the heapsort function. As I illustrated in previous video, max heapsort. We need to take the a and the index I. Alright, let's clear this. So we first get our left child index. Okay, left. I define the left. Okay, left of I and right of I. We first check if the left node larger than left child larger than parent. So I have the length as well. Heap size equal to length of A. If the L is equal to the heap size, and if the left index minus 1, so we get the correct number. These ones are all based on the 1 index, but for the real access of value, we need to -1. We record largest equal to L. Else, we do the largest equal to itself. Alright, then I know the largest. If the right one over the size and the right one larger the largest one. If it is larger, then we install the R into the largest one. Okay, and check if the largest not equal to itself, we do a swap. Okay, swap A, which one? Swap with the I and the largest. Okay, and we call itself. Okay, so this is the heapfile function. Let's test it. Let's do heapfile. Okay, so this one. So I have 40, 54 with 3 and 2, and then I change this one, so 45, 2 and 6, and I have 7 which is 7 and 2. Okay, so we have this kind of heap. It should be 54, 3, 45, 56, 2, 7, 6, 7, 8, 4, 56 and 2. Okay, so this heapfile function is correct. Another function we need to write is to build heap. Okay, it takes A as the result, and we'll check the first. It has a heap size. Heap size equal to length of A, right? And for I in range from 1 to n divided by length divided by 2. So heap size divided by 2. So we want to have heap size divided by 2. And it's a reverse order. So reversed order. Then we, for each I, we call max heapify, and that take the A and I. So let's do build a heap from the array. We call the print array. So we run this, the length. Okay, so here's the open. That's clear. So it'll give you this kind of heap. Let's check if it's correct. It's a correct heap. So 56, 56, 54, 8, 4, 45, 6, 7, 3, 2, 2, 7. So every parent is larger than its child. So this is a correct heap. So the heap file is finished. Then the last step is do the heap sort. Define heap sort. We take the array. We first build a heap. Build heap array. Okay, let's comment this out. Actually, take A. And then we need to loop from the 1 to 2. So from I in range, the loop from the length of A. So 2 to length of A, and we do a reversed. Okay, from largest to smallest. We do a swap. First swap, we have A. Swap what? Swap the L with 1. Okay, with the root. And then we do the, we need to have a track of the heap size. So in this case, we want to have a variable called a heap size in here, and this heap size will -1 each time. So we look from heap size to 2 to heap size, and then we do the heap size -1, max equal to 1. Okay, and then we call the max heapify, which is A. Okay, let's check if the logic is correct. So we have a heap size. I think I need to define the heap size. Okay, I need to define the length. Okay, so the length of A. So there's no heap size needed. So we call A, and then we need to track the heap size. Okay, so let's do heap size equal to length of A. Alright, and each time I reduce the heap size and then call the max heap file. Okay, let's do heap sort array, right, and then print array L, which is the left. Oh, not L. I need to swap with I. Sorry. Okay, so here is a problem. It's not work as I designed. So why? My heap size is -1. Okay, my max heap file do not tell the heap size. So I want to assign the heap size value to the function. So it's not depending on the A. Instead, it's depending on the here is I need to add +1 because the range is start from, you know what I'm saying here. So if I print a range of 2 heap size +1, for example, I print 2 to 4, it give you a 2 to 3. The 4 is not included, so here we have to have a heap size +1. Alright, now we have the heap sort working. Right, 2, 2, 3, 4, 6, 7, 7, 8. Okay, let's try another example. Array equal to 1, 2, 3, totally random, and then we perform the heap sort array and print array. For this one, so we have 2, 2, 3, 4, 4, 4, 7. So, okay, this is correct. So that is the implementation of heap sort. So what we have here is we need to have some way to get the parent, left and the right index, and we need a swap function. And in here we need to first figure out what's the heap file function we want to swap with the largest child, and do a recursion call for the heap file. And then we need to know how to build a heap from the array, which is we can check from the index with heap size divided by 2 to 1 to generate this heap. And then we need to do the heap sort, and the basic logic is you first build a heap and you record the heap size of the heap, and from the heap size until to 2 you do a swap operation. So you swap the root to the leaf of the heap, and then you reduce the heap size. So you exclude that one at the end, and you perform the max heap file for each root, for the root. So this is the implementation of the heap sort.